dusty. Okay, so we're going to do this again because the first time we did it was actually with the yo-yo. So you hear us talking about the yo-yo. This is actually called for. There's a washer on the end of the string. So we do that different lengths over our head. And you can, part of the experiment is with different speeds. And then slow it down. Of course, the thing is for the students to see the relationship between the amount of force being applied on the string and the speed. The result in the centripetal force and angle of the washer. And that's it. Oh, by the way, if you like the video, please hit the like and subscribe to the channel and check out some of the other videos if you have the time and inclination. Thank you. Said that fits. Then we'll fill it with water. And I think it's supposed to put the lid back on. Hope that it doesn't leak too badly. Invert it. So that looks kind of like what they have in the picture. It is leaking a little bit, so we're going to take it outside to do the actual experiment.
It looks kind of like the pressure diver.
You pause, please. I mean, I'll do.
The cork goes in a circle around it. It goes like no, it doesn't. It sticks to one side. No, it's
yeah. Now, is it going out or in this time?
I can't see.
Do it again. Oh, it's going in towards you. It's sticking.
Could you turn the wrapper so that?
Oh,
yeah.
okay.
It's making a circle around the bottle. It's sticking to one side.
Okay. Okay. Well, y'all want to try it?
Yes.
We can just
Pause.
pause, yeah.
It smells wonderful out here. Did you start it?
Mm-hmm. It's filming.
Okay.
So we're going to try this again. So we're going to do the same experiment. Of course, the washer is denser than the cork that was floating up. But we previously, this isn't part of the experiment, but we added this to see what happened with the washer hanging down in here and see if it gets the same result or not, or something different when we spin this around. The cork before, when we spun around, actually went inward, forced the stem out. So I'm just going to do this a little bit. See what. You got it? And the washer is actually going outward, just like when we spun around our heads. So we're going to figure out, speculate why we've got the difference between what the cork does. Because we already know why it is. We'll discuss that. So instead of a washer, we use a yo-yo on a string, since that's what we had to work with, a lot easier. So did y'all answer what happens to the washer as you increase the speed? Or in this case, the yo-yo. What'd y'all have?
The string becomes more horizontal as you increase the speed.
Okay, the string. Okay, what happened to the yo-yo?
I put the yo-yo gets closer to being horizontal when it's made faster. It gets more vertical when it is slowed.
What forces are acting on the yo-yo?
Your hand.
How?
And
My hand?
your hand is exerting a force by...
Is my hand directly touching your yo-yo?
No, but it's exerting a force on the string, which is tied around the yo-yo.
Which is tight, okay.
And there's friction with your hand and the string and with the yo-yo in the air. And there's gravity that's...
Okay, good.
And gravity between anybody's and mass.
As you spin the in this case, yo-yo around, inertia tries to keep the washer going in a straight line, right? The string pulls it back toward the center, and that's called centripetal force. So what is the relationship between the speed of the washer and the force you must use to spin it around? How do we increase the speed of in this case, a yo-yo?
Well, the force causes it to speed up and slow down.
So how does a force cause it? What do you do to the force to make it speed up or slow down? How are they related? Tell me the relation between the force and the speed of the yo-yo.
Well, I thought that when you exerted a greater force that it went faster.
Okay, so you increase the force, you increase the speed of the yo-yo, or whatever object you're applying the force onto. And if I decrease the force, it did what?
It slowed down.
It slowed down. Okay, good. Okay, a follow-up on the experiment on as you saw with the cork, when spinning around the cork went inward. Well, when we did with just as it floated, and when we did it with the washer hanging down in there, it went outward when we spun around. And that's why do you think this happens? So if you're a teacher, I ask what's the difference between the cork and the washer, and then what's the difference between of course, why does the cork float in water versus why does the washer sink? And of course, eventually it should lead to the difference between mass and density. And then thinking about that, centripetal force is kind of an artificial gravity. So when you're spinning around, the more mass or denser objects want to sink. In this case, want to go outward. So the water, being more dense than the cork, goes outward and therefore pushes the cork inward. And we see this the opposite with the washer, since the washer is more dense. And the other questions should be answered fairly easily by you and the students. If you liked the video, found this useful, please hit the like and subscribe button. And I'm going to try to get some more out there, and hopefully the quality of these will improve as we go along. Thank you for your time and your attention.